Okay guys, this is my second video for balancing equations, chapter 20. Should be pretty quick. I want to go through one more reaction. This one's going to be a little bit more challenging than the first two that we did. So I'll read off what it is just in case you can't see it well in the video. It's KMnO4, potassium permanganate, reacting with sodium sulfite, which is Na2SO3, plus water, yields MnO2, plus sodium sulfate, Na2SO4, plus KOH. Okay, so this reaction has more things involved. There's some things in there that I'm not really sure what I want to do. But if I look at it, if I assign charges everywhere, I'll basically find out that manganese is going from +7 here to +4 here. And sulfur is +4 right here, and it goes to +6 right here. So if you kind of assign all the charges and everything, what you find is that manganese is being reduced and sulfur is being oxidized. You need to be able to identify that because that's going to help me write my half reactions that I need. The problem with this reaction is there's a lot of extra stuff that's being transferred back and forth, but honestly, the manganese and the sulfur are the important things. A lot of the other things present are just spectators. Specifically, the potassium and the sodium, they're switching places, but if we remember in double displacement reactions, if we look at this reaction with physical states, pretty much everything here is going to be aqueous, except the MnO2 is probably going to be a solid. But if the other things are all aqueous, what that tells you is the sodium and potassium, they're not really with the permanganate or the sulfite or the sulfate or the hydroxide. They're floating freely. So I would probably have a better time writing this reaction if I looked at the net ionic equation instead of the total ionic equation. So, net ionic equation, the potassium and sodium is going to cancel. Even though at this point, I don't know how many there will be in the balanced equation. I know that none of them are doing anything important, so I'm going to get rid of them. I'm going to rewrite the reaction without the extra stuff. I'm going to have permanganate plus the sulfite ion are going to react to make MnO2 plus the sulfate ion. Now, what about the other stuff? Well, like I said, potassium and sodium are spectators. Water molecules in aqueous solution, if you remember in our procedure, we'll put waters in when we need to. We're probably going to have waters involved in both half reactions, but then when we put them together, some of them are going to cancel out, and we'll figure out how many we have by the end. Same thing with the hydroxide. Now, this reaction in the PowerPoint, it actually said we want to balance this equation as if it's in a basic solution. In an acidic solution, we tend in our final equation to have some H pluses floating around, but realistically in a basic solution, there aren't very many H pluses floating around. There tend to be a lot more OHs. Excuse me, so there's a shift that we have to do at the very end of the procedure to address that. So I boiled my reaction down, I got rid of the spectators. I'm not really worried about water and hydroxide until the very end. So let's just focus on the main participants. That's going to simplify everything down, and I'll add everything else in later. So I'm going to look at my half reactions. The manganese half reaction is going to be MnO4 minus yields MnO2. Follow the procedure. Balance manganese first, one on each side, it's good. Balance oxygen, there are 4 here, 2 here, so I need 2 waters on the right. Balance hydrogen, I need 4 hydrogens on this side, or I have 4 hydrogens on this side, so I need 4 over here. And then balance charge, on the left I have +4 minus 1, so a +3. On this side I don't have any charge. I'm going to add the electrons to the high side and bring it down, so 3 electrons. Now, a reminder, you've got to be really careful about doing everything in order. You have to balance the other element and then oxygen and then hydrogen and then the electrons. If you do any of that out of order, the whole process falls apart. You've got to stick with it. Just do it the way it's supposed to be done. Everything will work. So that's my first half reaction. The other one, SO3 2 minus becomes SO4 2 minus. Balance sulfur, good. Balance oxygen, I need 1 water on the left. Balance hydrogen, I need 2 H pluses on the right. Charge, -2 over there, -2 plus 2 is 0 here. So I'm going to add 2 electrons to bring 0 down to -2. Okay, so that's my balance half reaction. You should be able to see at this point, once you get the pattern down, this should be a very fast process for balancing each half reaction. At this point, I've got 2 electrons here, 3 there. My lowest common multiple is 6. So I'm going to multiply the whole first reaction times 2. Everything in there times 2. And the whole second reaction times 3. Okay? You could rewrite all that to be careful. I'm just going to say there's going to be a 6 here, an 8 here, a 2 here, a 2 here, and a 4 here. And then on this one, it's going to be a 3, a 3, a 3, a 6, and a 6. Then I combine everything. This is where I need to be kind of careful. So my 6 electrons are going to go away on that side. My 6 electrons over here. I have 6 H pluses here, so they're going to go away. I had 8 here. When I take away 6, that's actually going to leave me a 2 here. And then waters, I've got 4 waters over here. I've got 3 here. That 3 came from the distributing right here. So the 3 is going to go away. This is going to drop to be 1. So now I'm going to rewrite. I've got 2 H pluses plus 2 NO4 minuses plus 3 SO3, 2 minuses, yields 2 MnO2s plus 3 SO4, 2 minuses, plus a water. And I think that's everything. So at this point, I would say I've got 2 manganese, 3 sulfurs, 3 sulfurs, hydrogens, just 2 hydrogens over here. Oxygen's gonna be 4, 12, so 4 plus 12 is 16, 17. Here I have 9 and 8, that's 17. I think everything works. Charge-wise, -2 and -6 is -8 plus 2. So that's going to be a -6 on this side. Over here, I just have a -6 also. So that does work. Everything balances out. This is the balanced equation in acidic solution. This is always how we're going to balance the equation initially. We balance it for acidic solution first every time. If the problem says balance it acidic, you're done. If the problem doesn't tell you whether it's acidic or basic, we'll just assume it's acidic and we're done. But if the problem says it's basic, then there's one more step we have to do. We need to add hydroxides to get rid of the H plus. And the way we do that is if I have 2 H pluses, I'm going to add 2 OH minuses. And if I combine 2 H pluses and 2 OH minuses, they're going to combine to become 2 waters. But this is a balanced equation. If I add 2 H pluses to my left side, I need to add 2 OH minuses to my right side also. I have to add the same thing on both sides. So I'm going to come over here and also add 2 OH minuses. And then the last thing, I just created some more water. 2 waters on the left. I already had 1 water on the right. So again, I gotta get rid of the smaller one. The 1 water is gonna go away. Take 1 away on this side. I need to take 1 away over here also. That's gonna become a 1. So now if I just kind of clean up what I've got, I'm gonna have 1 water molecule on my left, and I'm gonna get rid of that and shift over. I'm gonna have 2 hydroxides on my right. So that's now my cleaned up balanced equation. Just keep track of everything. Make sure that you, when you cancel things out, that you mark it properly and then rewrite the final, okay? The last thing I need to do here though, it gave me the problem involving sodiums and potassiums. I need to throw them back in there. So I have 2 NO4 minuses, but that was originally KMNO4. So technically, I should go back and replace that. It's going to be 2 KMnO4s. Okay? The sulfite was actually sodium sulfite. So that's going to be 3 Na2SO3s. My MnO2 is the same. My sulfate should be sodium sulfate. So that's going to be 3 Na2SO4s. And then my hydroxide is actually KOH. And now, if you go back and check, I have 2 potassiums, 6 sodiums. Everything actually balances out. And remember how they gave me the water in the beginning right here? Well, it's on the left side. There it is. And they gave me hydroxides on the right. I ended up with hydroxide on the right. I mean, it all works out. But initially, they gave me so much information. If you try to deal with all of it in the beginning, you can't do it. The process doesn't work if you have too many things to look at. So the key there was, when we started the problem, we boiled it down to the net ionic equation. Once we had that, then everything else we did was simple, just like we've always done it, up until that last step we haven't seen before, which was adding hydroxides to get rid of the H pluses. Okay, that's it. We are done with chapter 20. That's the last video that you'll see from me.